Hello everyone, welcome back. Today we would be discussing about the Krebs cycle. It will all start with the formation of the pyruvic acid from the glycolysis process, and here two molecules of the pyruvic acid is being formed, and it will enter into the matrix of the mitochondria. This process it is undergone as also link reaction, and first of all, when pyruvic acid enter into the mitochondrial by the help of the pyruvate translocator and also by the help of the protein channels, it is being moved from the cytoplasm to the mitochondrial matrix. Then once it entered into matrix of the mitochondria, it is being captured by the so many number of the vitamins also. Here we see lipoic acid, which is also called a B complex, thiamine pyrophosphate B1, and FAD we also call a vitamin B2, NAD it is also equal to vitamin B3, and another component magnesium coenzyme A is also called as a B5. These are all of them are acting as in cofactors, and also these are helping out to remove the carbon and also adding up the hydrogens to the NAD plus, and also removal of this also take place here. Now NAD plus is being attracted towards that, and then NADH2 is being moved out. Then coenzyme A is the one which is entering into the process. Then pyruvic acid, which is a 3 carbon compound, it is losing one of the carbon in the form of carbon dioxide. Then it becoming the acetyl. Then coenzyme A is interacting with the acetyl coenzyme A. This is what the entire process which mediates completely around the pyruvic acid to acetyl coenzyme A. Then the Krebs cycle starts with acetyl coenzyme A, which is also considered as a cyclic process here. Coenzyme A is just helping out for taking up the water, and this we call it as an hydration, and mixing of the 4 carbon compound call it as an oxaloacetic acid. Oxaloacetic acid plus acetyl coenzyme A combined with each other and then forming the citrate, that is called as a 6 carbon compound, also citric acid also we can call it. Now coenzyme A again move back, then go back and again combines with the another side, another acetyl coenzyme A. Then citrate which is formed here again loses water molecule by the help of an aconitase. What is this aconitase means? It is just helping out for the formation of isomerized structure only, means same structure only different positions here. Cis aconitic acid is being formed. Again there is an entry of the water molecule, then with the help of aconitase only same, and again it is forming isocitric acid. And why this whole process has been happening? Because they were just changing the positions of the carbon so that it is easy for the breakdown of the carbon and also to release of that energy also. Next, isocitric acid losing the carbon in the form of carbon dioxide. Then in the presence of an enzyme decarboxylase also, alpha ketogluteric decarboxylase, and also dehydrogenase is also helping out. Then NADH2 is formed. Here one NADH2 started in the Krebs cycle. Now what is this means? It is a link reaction. It doesn't involve in the Krebs cycle. Krebs cycle starts when the citric acid is the forming, which is a stable product in the Krebs cycle. Then alpha ketogluteric acid, which is a 5 carbon compound, it is formed. Again, it has lost the one of the carbon. Again, NADH2 in the presence of this decarboxylase and also dehydrogenase. Then coenzyme A is entering into the process. Then it has lost the one of the carbon. Then it became the 4 carbon. That is called as succinyl. Succinyl combined with the coenzyme A, again there is a cyclic process. Coenzyme A combines, again releases, again combines, again releases. Here there is a substrate level of phosphorylation is been forming. What was that means? GDP is forming the GTP here. Again GDP it is forming, again losing the phosphate. Now this phosphate is being accepted by the ADP, then forming the ATP. Finally, we are going to get the ATP from the process of this Krebs cycle. Here, substrate level of phosphorylation means direct releasing of ATP is called a substrate level of phosphorylation. Then succinic acid is been formed. Again, coenzyme may combine with another succinyl molecule. Then succinic acid with the help of the fumaric dehydrogenase, then again FADH2 is been formed. It has lost it. Now here malonic components are the ones malonic which is acting as a competitive inhibitor to succinic dehydrogenase. Then fumaric acid, again hydration takes place, entry of the water molecule becomes a malic acid, which is also considered as a 4 carbon compound. Now malic acid loses its hydrogen, then NAD plus accepting the H plus and also H plus, then it is becoming NADH2. Here the third NADH2 has been produced in the Krebs cycle. Finally, oxaloacetic acid is being formed. This is being managed by the other components. So again oxaloacetic acid combined with the acetyl. Like this, for 2 pyruvic acid, 2 Krebs cycle is been taking place. And we know that 1 NADH2 is equal to 3 ATP and 1 FADH2 is equal to 2 ATP and also 1 GTP is equal to 1 ATP. Now, how many number of NADH2 has produced? 3 of them in the Krebs cycle. That means 3 into 3, 9. 9 ATP they can produce when entered into the ETS. Then 1 FADH2 is equal to 2 ATP. Here it is directly releasing the 2 ATP. Then there is an 1 ATP production directly. Now total number of ATP in the Krebs cycle is only 12 number of the ATP. Then what is the number of ATPs produced in the link reaction? In the link reaction we have seen the only one NADH2. That means it is equal to 3 ATP. So it is equal to 15 ATP. This is per 1 pyruvic acid. So like that we need one more pyruvic acid because 2 pyruvic acid is released from the glycolysis process. So we got the 15 plus 15. That means total number of the ATP they may produce is 30. Then from the glycolysis process we got it like 8 ATPs. That means we have seen the 2 NADH2 producing, then 2 NADH2 is equal to, it is 6 ATP and directly 2 ATPs been released out. So we can say that here it is 8 ATPs produced. So 30 plus 8 ATPs, totally we conclude that 38 ATP molecules are produced in the aerobic respiration. Still it is not yet finished, students. I'll come back to you with the ETS system. We'll calculate number of ATPs, how may they produce. Thank you for watching.